All right, in this example today, we're going to review one sample t-test for means. Okay, the actual problem we're going to do is a paired t-test where a single subject gets both treatments, and all we care about is the difference between each of those treatments. So let's look at the example and we'll see what we're talking about. So here we're looking at car dealers to see if they tend to charge more for women or men on the same model car. We have 8 different car models. In the table, you see the prices charged for men and women, and the third line, they've calculated it for you, is the difference. Like car number 1, they charge the woman $520 more than the man. In car number 2, it was the man $100 more than the woman. Fortunately, also for you, in this problem, they've already put the data into the calculator and calculated the mean difference in mean standard deviation, the bottom line. So the average of all the 8 differences was an average difference of $585. And because it's woman minus man, we basically see that they, on average, charge the woman more than the man. But is it statistically significant difference? We'll have to see. And there's the standard deviation, 530.71. So we do our 4-step plan. We state the hypothesis. Mu of D, okay, that's the mean difference, is 0, which basically is saying there is no difference in the prices. We want to see if they charge the women more than the men, and so we say mu of D is greater than 0. Is the difference positive? Where mu of D, and we always state that where the difference is woman minus man, okay? Then we plan. We look at the conditions. Random, yep. We said it's 8 randomly selected cars, so it passes the random test, the 10% rule, are they independent? Well, we should assume there's 80 different model cars they could have chosen from. And normal, well, their sample size is only 8, so we can't do the over 30, assume it's normal, so we have to look at the graphs. So let's check the graphs. We have 3 graphs. The graph of women only, men only, and the graph of the difference. We actually don't have to pay attention to the women and men graphs. All we care about is the graph difference, okay? And we're looking, are there any outliers? Is there any strong skewness? Does it look fairly symmetric? And it really passes all those, so we can assume that the differences are approximately normal, therefore it passes the normal condition. Then the do, we calculate the test statistic. We need to find the mean difference and the mean standard deviation. This problem was given to you. If it wasn't, you'd have to put the differences into list 1 and do 1 var stats to get the mean and standard deviation. So we define the t statistic. Remember, it's the statistic minus the parameter. 585 is what the actual difference was. We're hypothesizing that there's no difference, so that's why it's 585 minus 0. And then the bottom is how to calculate standard deviation for a mean. And we get a t statistic of 3.12. Remember, that's not quite the same as a z, and so we have to go and remember degrees of freedom is 7, and we have to go to that t table under degrees of freedom 7 with a t statistic of 3.12, and we find out from that that the actual p-value from the table is between 0.005, which is 0.5%, and 1%. If we did it on a calculator, we find out it's 0.8%. Okay? And from that, our conclusion is p is definitely small. So since p is small, you reject the null hypothesis that there's no difference. And so therefore, we have convincing evidence that the purchase price for the cars is greater for women than it is for men. So now you have 2 problems I've placed for you to practice on. They have not calculated the differences or given you the mean and standard deviation, so you're going to have to do that on your own. Follow the hint and please complete the 2 problems under topics.